these monthly spotlight students figure out 14 of them. Okay, so all of them figure out 14 of those problems. So they were ranked together on number 1. So they are recognized as the monthly spotlight students. Okay, let's move on to today's discussion. So first, I have this problem. If we define A sharp B, okay, if we define A sharp B equals AB plus A plus B, and then the question is, what is 1 sharp 9 sharp 9 sharp 9 sharp 9 sharp 1? Okay, so that is the question. So let me see, is a Q here? A Q here?
Yeah.
So you're the fastest one to figure out this question. So I want to hear from you about your solution.
So so for the 1 and the 9, I made 19, but then but each 9 after that added another 9.
So let's do this step by step. You said 1 and 9 makes 19. Why is that?
Because 1 times 9 plus 9 plus 1 is 19.
Okay, so this equals 1 times 9 plus 1 plus 9. Okay, so this is 10 plus 9. This is 19. Okay, that's why 1 sharp 9 is 19. Okay, keep going.
So then after that, each of the other 9s added another 9 after that.
So why after that each 9 add another 9? So let's do 19 sharp 9. Why is it adding another 9?
Because
so let's go through this, right? So if it's 19 and 9, so that will be 19 times 9 plus 19 plus 9, right?
Yeah.
So how did you figure out it's just adding another 9? How did you figure out this is 199?
Well, for this one, I did 19 times 9 is 171 and then added.
So 171 equals 171 plus 19 plus 9, and then it's 199. So basically you find a pattern, right? So you find this pattern.
Then I realized that like 9s, like for the 9s, it's like there's like a like for like 99, it's basically the 9 table except there's a 9 in the middle. So for the 999, there will just be 2 9s in the middle.
Okay.
Plus the 1 time plus the like 10 times 9, which gives you 90.
Okay.
So if you add all that together, you get 1, 7, 1 with however many 7s in the middle, and then when you add the 9 plus the 19.
Okay. So you're trying to, you're basically multiplying the first 2. If it's 199 times 9, and then you multiply these and you find 1, whatever 9, and then there's a 7 and a few 7s probably. And basically, your strategy is to multiply these, the first number and the second number. You follow this arithmetic and then get this 199. And then for this, all these 9s, you just do 19999, right? That's what you did?
Yeah, and then once I got to the 1, it was just 1 times 19,999, which just gave 19,991 plus that, and then we add plus that plus 1. Okay. And that gives you a total of 39,999.
So this is basically this number times 2 plus 1, right? So that's why it's 39999, right? So that's the answer. Correct?
Yeah.
All right. So any other solutions to this? 2 participants raise hand. Let me see who raised hand. Ryan and Kyle. So Ryan, why don't you give your solution?
Oh no, I have a question.
Oh, you have a question? Okay, go ahead.
So when I was solving this, I assumed that AB would just be the two numbers put together. So I assumed that AB was 19, and then I added the other two numbers.
Oh, so you thought AB is just, you know, it's AB is one number with two digits. One digit is, and one is B. Oh, okay. Right. So this is not. This is AB means A times B.
Mm-hmm. But the last time I think, let me check.
Yeah, that was a different problem. So previously we had different problems. So here we didn't say if AB represent two digits, then we'll say A and B represents, you know, single digit number or something.
Okay.
Right. There are easier solution than what Akil's. Okay, Leo, go ahead.
Well, I basically wrote down the equation. So I basically like just know that like 1 times 9 equals 9.
Hold on, let me copy. Okay, so you wrote down what? 1 times 9
equals 9.
Equals 9. Okay.
And like I kind of knew that 1 sharp 9 was 19.
Okay, 1 sharp 9 is 19. Okay.
So I first put 19 in the middle of the equation.
Okay.
And then.
So 1 sharp 19. I mean 19 sharp 9.
19 sharp 9 is basically equal to 9 times 19 plus 1 times 19 plus 9, which equals 10 times 19 plus 9.
So this is equal to, well, 19 times 9 plus 19 plus 9, right?
Yeah, which equals 10 times 19
plus
9.
So you're using a rule. What is that rule again? What is that property?
Distributed property.
Right? So look, when Leo come to here, he realized this is the same as 19 times 9 plus 19 times 1, right? And then here we add another 9. So then you can take 19 out. This equals 19 times 9 plus 1, right?
Yeah.
Plus 9. And 9 plus 1 is 10. So this becomes 190 plus 9. So this is 199, right? So basically, he, instead of, you know, doing the multiplication of this, 19 times 9, or 199 times 9, or 1999 times 9, so he figured out, okay, if every time we're multiplying 9, let's say there's a, right? So all these, the first few b's, they're all 9. If we do a times 9 plus a times 9 plus a, it's the same as a times 10, right?
Yeah.
Okay, so that's I consider a shortcut. So basically, when you realize when every time you do a sharp 9, it's just equivalent to times 10 plus another number plus the plus b, then you know you're adding knives after once, and then all you need is do 1 followed by 4 knives, sharp 1. Okay, this is 19999 times 2 plus 1, right? This is 39999. Okay, any questions?
I have another solution.
Okay, go ahead, Kyle. Is that Kyle?
Yes.
Okay, go ahead.
Well, this is kind of like Leo's, just a little different.
Okay.
So, A sharp B equals A times B plus A plus B, and that is also equal to A plus 1 times B plus 1 minus 1.
Okay. A plus 1 times B plus 1 minus 1. Okay, let's break down A plus 1 and B plus 1. Okay, A plus 1 times B plus 1 equals AB plus AB plus A plus B plus 1, right? So this is the same as AB plus A plus B, and then you know here you add 1, so you have to subtract 1. Okay, go ahead.
And then you apply that rule to the actual equation. So 1 sharp 9 is 19.
1 sharp 9 is 2 times 10 minus 1. Okay.
Well, I still keep the. I don't yet do the 19 yet because everything is 20 minus 1 plus 1 times 9 plus 1.
Okay. 20 minus 1.
So that is 2000 minus 1.
Hold on. So you said you don't use 19. What do you use?
20 minus 1.
Okay, 20 minus 1. Okay. And then, okay, then you do 1 sharp 9, sharp 9. That becomes 20 minus 1 plus 1, right?
Yeah. Times
9 plus 1.
9 plus 1. So the minus 1 and plus 1 cancel out.
Okay.
So it gets 20 times 10 minus 1, so
20
it's 200
times 10
minus 1.
minus 1. Okay. This is 200 minus 1. Okay.
Mm-hmm.
All right. Then you keep doing this. So the next one will be 2000 minus 1. Then the next one will be 20,000 minus 1.
And then it and then the 1 sharp 9 sharp 9 sharp 9 sharp 9 sharp 9 sharp 1 I mean is 2000 minus 1 plus 1 times 2, which is
Equals
20,000
20,000, right? 20,000 minus 1
plus 1.
minus 1 plus 1 times 1 plus 1 minus 1, right?
Mhm.
Okay, so this is 40,000 minus 1. Good, this is smart, okay? 39999, right? Excellent. All right, good idea, right? Any other solutions to this problem? If no, let's move on. So the next problem is about perfect squares. Please mute yourself. Okay, so let me see who want to talk about this one. Is Kenny Chen there? Kenny Chen? Yeah. All right, so you're the fastest one on this problem. So can you share with us your solution?
So I knew that 4 squared is 16, so any number bigger than 4 would be in the range.
Okay, so because we're looking for perfect squares, and then between 20 and 20. So you look for the largest perfect square below 20 will be 4 square. Okay, keep going.
And then I knew that 45 squared is 2025.
Okay, so 45 square is 2025.
So it's between 4 and 45, and there is 40. So it's 45 minus 4 minus 1.
Okay, so basically
it's 40.
Boil down to how many numbers, how many natural numbers, or how many whole numbers are between 4 and 45. So then this basically 45 minus 4 minus 1 is 40, right? So the answer to this question is 40. Very good. Any other solutions to this? Okay, so this is one of the easier ones, but still, you have to know how to count, right? And you need to realize 45 square is just right above 2020. Okay, let's move on to the next one. Okay, this one is a bit tricky. So find the 2020th digit after decimal point of 2020 divided by 7. Okay, what is the 2020th digit after a decimal point? Please mute yourself. Okay. Well, for this, find who's. Yeah, please mute yourself. For this problem, I want to hear, is David Tian there? David not, okay. Let me see who else want to talk about this one. Is Jana Zaidman there? No? Okay, then whoever want to talk about this, just unmute and announce your name, and wait for my permission, then you can go ahead, okay? Who want to talk about this problem?
Can I go?
What's your name?
Kyle?
Kyle? Well, since you already answered one question, let me see if there are other students who want to talk about this one. Any other students want to talk about this problem? You can just, who's that?
Raghav?
Oh, you're back. Okay, so
Yeah.
well, you're the spotlight student, and we meant to have you introduce yourself and talk about your favorite things. Since you're
Okay.
back, so why don't you first spend a minute talking about yourself, and then introduce this problem.
Okay, I'm Raghav Arun. I go to Elam Park Elementary, and I'm in 5th grade. And my favorite thing about math is probably number theory.
Oh, number theory. Okay, well, this one right fits your appetite, right? This
Mhm.
is a number theory problem.
Yeah. So
Okay, go ahead.
the way I solved it was first I divided 7 into 2020,
Okay.
and I got 288. And then I started writing the decimal.
Oh, you started writing decimals. Okay. Okay. You just do the long division. 2020
Yeah.
divided by 7. Okay. So you got what? 288. Dot what?
5,
Mhm.
7, I think.
5, 7, 7. Yeah. 1,
And then
4,
1, 4.
8.
Yeah.
Yeah. Okay.
No, it's 1428.
Oh, 1 more 2, 8. Yeah. 2, 8. Okay.
And then I divided. The sequence is a 6-digit sequence because after 8 it starts
After
repeating
that
all
is another 5, 7, 1, 4, 2, 8. Right?
Yeah, so you
Another 8.
No.
After the 8 is another 8.
No. There's no other 8.
no, it's another 5.
Yeah. So this is the sequence. Every 6 repeat itself, right?
Yeah, and then so I did 2020 divided by 6.
Okay.
Got the remainder to be 4. So the
Because
4
we're asking for the 2020th digits. So you did another 2020 divided by 6. This one is something remainder 4, right?
Yeah,
Okay.
and then the 4th digit in the sequence is 4.
Okay. So the 4th digit is 4. So the answer to this problem is 4. Okay. Any questions to this problem? So here, I mean, this will be what I would do. I mean, I did something very similar. So, okay, some of you said you did the same. Okay, I did very similar. So, but first I did 2020 divided by 7. I got 288, and there was a remainder. Remainder was I believe remainder was 4, something like that. Okay, and then I did 4 divided by 7. I got 0.57148. It's a 6-digit sequence. Okay. And then here, there's one thing a little different. So, Raghav, I want to ask you, how did you figure out this remainder 4? 2020 divided by 6. How do you know its remainder is 4?
Because I know 2016 is divisible by 6.
Oh, you know 2016 is divisible by 6. Okay. Well, how do you know that?
Because it's a multiple of 3 and it's a multiple of 2.
It's a multiple of 3, and this is the even number, so it's a multiple of 2, and this is 2 plus 1, 0 plus 1 plus 6 is 9, which is divisible by 3, so this must be divisible by 6. Okay. Any other ways to figure out the remainder of 2020 divided by 6?
You just do the long division.
Okay, so another way is just do a long division, right? So 2020 divided by 6, right? So you can do that, right? How about this? Let me ask you, if I do 20, so this number. If I do this number divided by 6, what's the remainder?
4.
Who said 4?
Raghav.
Why is this also 4?
Because like I just did the long division really quickly.
Oh, you did a long division on this?
Yeah. So 2020 divided by 6 gets a remainder of 4, and 420 is divisible by 42 is divisible by 6. So I get rid of that, and 0 doesn't mean anything. So you back to 2020 again.
Oh, okay. So then let me give you a different one. So how about this? 4, 1, 4, 1, 4. Okay, what is this number divided by 6? What's the remainder?
Remainder 2.
2.
Yeah, 2.
Who said 2?
Me,
Me.
Well, you have to say your name.
Kyle.
Okay, why is the remainder 2?
Actually, there's also another trick in this.
Okay.
4 plus 1 plus 4 plus 1 plus 4 equals 14, and 14 mod 6 equals 2.
Oh, okay. 14 mod 6 equal to, oh, some of you say you use a calculator, all right? So don't use a calculator.
Actually, doing 14 mod 6 isn't always gonna work because if it's an odd number, then it might not.
Who's speaking?
Akil?
Akil. All right, so Akil said, well, this strategy may not work if this is the odd number. So let me change it to odd number, okay? How about 1 4 1 1 4 1 4 1 divided by 6? What's the remainder?
2.
2. Why is it 2?
Same thing.
Wait, that's impossible. That's impossible.
Huh? What's impossible?
For the remainder to be true.
Yeah, this cannot be 2, right? Because 6 is an even number. If this is an odd number divided by 6, remainder cannot be an even number.
I got 5. Not divisible by 3.
What is the remainder for this?
I got 5.
2 plus 3?
Huh?
2 plus 3.
2 plus 3? So let me go back to this 2020 thing. Okay, there is a strategy. So I think Akil already said it. So if it's an even number, okay, if it's an even number, right? Look, this is 2020, right? 2020. I know 2 plus 2 plus 2 is divisible by 3, right? So this is 6. This is divisible by 3. Okay. This 2020, if we add a 2 to 2020, that become an even number. That means it's divisible by 2. And we have 3 2's that are divisible by 3. Okay. So if we add 2 to it, that number would be divisible by 6. So 2022 is divisible by 6. Okay. Since we added 2, so that means when we divide by 6, the remainder has to be 6 minus 4. I mean 6 minus 2 equals 4. That's why its remainder is 4. Okay. The same as 1 4 1, 4 1 4 1 4 1 4. Okay. So these numbers, when you add up these numbers together, it's 10. No, it's 14. Okay, 14. If we make up 18, if we add 4 to it, if we add 4 to here, that becomes 4 1 4 1 8. This is divisible by 6. Okay, because 4 plus 1 plus 4 plus 1 plus 8 is 18, which is divisible by 3, and this is an even number. So that's why in this case, if you added 4, it would be divisible by 6. So this number is divided by 6, the remainder is 2. Okay? So you can make up, because 6 is a good number. It's just it has the property of divisible by 3, and it's an even number. So as long as you come up with an even number and all the digits add up divisible by 3, then that number is divisible by 6. Okay? So there are strategies you can come up with a number that is divisible by 6. Okay. All right. Any other questions to this? So the next one.
Baby.
Who's speaking? So let me see who will talk about this problem. I have. Oh, Akil and Raghav already talked about your solutions, right?
Yeah.
Okay. So let me see. Is Qizheng Lei here? Qizheng? No? Okay, William, go ahead.
Well, I just saw if there's A, B, C, D, E, F, and G,
Mhm.
and they are all consecutive prime numbers arranged in increasing order. If some of them has a prime factor 2, what is the product of them? Well, I look at it. Well, if they're consecutive prime numbers arranged in the, well, let's focus on the prime factor 2. All prime numbers are odd except 2. So
Okay. So here's a fact. You just mentioned it, very important. All prime numbers are odd except 2, right? Okay, go ahead.
and then you see there's 7 numbers, and you know that 2 has to be one of them.
Okay, there are 7 numbers. Okay, 7 numbers. If 2 is not there, then you add up odd number of odd numbers. Then the sum has to be odd, right?
Yeah.
So then that means 2 has to be there. Okay. 2
Okay, so then
has to be in the group.
so since 2 is the smallest prime number,
Okay.
you know that it's 2, 3, 5, 7.
Okay. So 2 has to be this. Basically, A has to be 2, right?
Yeah.
So we have 2, 3, 5, 7, 11, 13, and 17, right?
Yeah.
Okay. Keep going.
I noticed there are 3 of the numbers there that are really special. 7, 11,
Oh.
and 13.
Which 3 numbers are special and why are they special?
7, 11, and 13.
Okay, 7, 11, 13. Why is it special?
Because they make 1001, and it's really easy to get the product if you had 1001 as a.
So at this stage, I mean, some of you may just do the multiplication, 2 times 3, and then 6. 6 times 5 is 30, and then times 7. Keep doing that, right? But here, William figured out, 7, 11, and 13. They are, they're special primes because the product of them is 1001, right? Okay, so you multiply these 3 numbers first, okay, and then.
And then I multiply 2, 3, 5, and 7.
2, 3, 5, and 7. Okay, when you multiply this, I bet, well, you can, you probably do 2 and 5 first, right? So that's 10.
Or 17.
Yeah,
Oh, 17, sorry. 17. So 2 and 5 here is 10, and 3 times 17 is 51. So you got 510, right?
And I know if you times one number by if you time one number by 1001, you're just gonna get the number 2 times.
Okay, so if you time 510, multiply 510 and 1001, basically you just write 510 2 times. Okay.
Yeah.
Right. I mean, you only do this when the first number is 3 digits or smaller. Right? You can't do this for say 9999 times 10001. It doesn't work that way. Okay. I mean 1001. Okay, 1001. So this number has to be a 3-digit number or smaller, right?
Yeah.
Okay. Any questions? Okay, if no questions, we are done for the day. So I will assign you another set of problems today. You can work on it. Please work hard on those problems. Think about them and see if you can find an easy way to solve them. Okay, and in order, so the new set of problems will start the race for Spotlight students of May. Okay, then hopefully some of you can become the Spotlight student of May, right? Again, congratulations, Raghav.
Thank you.
All right. So have fun, guys. Bye.
Bye.
Bye. Thank you.
Bye.
Thank you.
Bye.
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 Close.